In this video, I want to walk through some of the data types in Cloud Firestore. At this point, you're working on your final projects. You may be putting data into your database that we haven't covered in building that movie rating app. So I want to go through a few of these in a little sample application to give you a sense of how to use some of these. So in Firestore, you can use any of these types in your documents as fields. As values in your fields. So you can have a field that has an array, a Boolean, bytes, date time, floating point, geographical point, integer, map, null, reference, text string. And some of these are really straightforward. Like an array, all you have to do is create a JavaScript array, throw it into a field in your document, and there you go. Same with a Boolean. But some of these, like date and time, geographical point, and reference, are specific to the Firestore API. So to generate these and put them into our database, we actually have to talk to the Firestore API, use some of the methods that come with the Firestore API to construct an object that is a geographical point, or that is a date time, or that is a reference. And then once we've constructed those, we can store them into the database. Okay, so to get started, I recommend having this Firestore documentation page open for the data types over here, and then also pulling up the reference page for Firestore, because we're going to be referring to this as we create instances of date, time, geographical points, references. And then you're also going to want to have a Firestore database that is set up for you to use. I'm just going to reuse the one that we've been building in our movie rating app, and I'm going to put a new collection in here. And that collection will just be collections of people. I'm just going to do one person in this database. So I'm going to take Grace Hopper, who was one of the early programmers and was like really instrumental in coming up with programming languages that read like English, used English words instead of mathematical symbols. So I'm going to create an entry for her in a collection here of people. But I'm going to do all of this from our JavaScript project. So you can download the starter files, and once you open them up, there are a couple things to do for setup. Make sure that you copy your .env.template and rename it to be env.local and fill it out with all of your API information from Firebase. And then also run npm install to install all of the dependencies. Once you've done that, you can npm run start to get this up and running. And there won't be really anything interesting in this React application. I'm going to open up my console window here, and I have a button for adding Grace Hopper to the database, and then a button that'll print out the database info to our console window here. The only reason we're using React in this demo is just so that we can have a button that when we click it adds data to the database. We are not really concerned about how to get information from a form into the database and how to print information from the database onto the page. That's all stuff that you know how to do. I just want to focus on how do we put these data types into our database? How do we pull them out from the database? So one change that I've made to this starter file is that we have our Firebase configuration that goes on here, where we import the Firebase library, we import the Firestore features so that we have them available. We go ahead and configure using the environment variables, our Firebase application. We initialize the application, we create our database, and then down here I'm exporting both the database and Firebase, the Firebase library, as named exports. So I'll be able to import them in curly brackets like this into other files. And this exporting of the Firebase library here is new. We didn't do that before, and we're going to need this for generating our timestamps and our geographical points. So other than that, it is just an application that loads this app component here from my app folder, which has 2 buttons and on-click handlers that are marked as asynchronous. So we can do our try-catch promise logic with async and await. So to start with, I'm going to go ahead and import Firebase here. So I'm going to import my DB and Firebase from data Firebase so that I have access to both of these. And we're going to start with adding data, and then afterwards we will print all of the data that has been added. So to start with, we need to get a reference to the people collection. And in Firebase, we can, even if there isn't one in our database here, we can start a new collection by getting a reference to that collection and then calling add. So we can say peopleref.add and then pass in new data there. So looking at our data types, maybe I'll try and bring these up side by side here. We've used strings before. Those are easy. So if we wanted to put Grace in here, we could say first name, Grace, last name, Hopper. And here I'm ignoring her middle names, but we could also create fields for storing those. And one kind of design consideration that you want to keep in mind when you're storing this is like we could put her whole name into one field, but then if we asked Firebase to Firestore to sort that data based on that field, we would be sorting based on that full name, starting with the first name. And when you separate them out, so you have first name, last name here, you can sort on either the first name or the last name. Okay, so our add here returns a promise. So if I were to await that promise and go ahead and wrap this in a try catch, I'm going to print out any errors that occur. And here again, we're really not doing a full React application. This is just a simple data type demo that happens to use React for the interactivity. So we're not going to really capture the error and display it on the page like we normally do. Here we're just throwing to the console so that we can see things happening as we're working. And let's do a console.log added Grace. So I have something that reaches into the people's collection, adds a new document in there that has Grace Hopper. So this button, the add Grace Hopper button, is linked to this onSampleAdd function. So when we click, that will be invoked, and this is an async function, so we can do our await with a promise here. So we should be in a place where if I come over here, let's open up my console. Add Grace Hopper. Took a second, then said it added Grace. And if I go back to my Cloud Firestore and I refresh the page, I should see under people a new entry for Grace Hopper. So cool, we got that working. I'm going to go ahead and delete this document so that we can add it again. Without having duplicates in here. So I'm going to delete this document. And now we can focus on adding some of these other data types in here. So maybe we will add a Boolean for whether or not the person that we're adding into this people's collection is currently alive. So Grace passed away in 1992. So adding a Boolean here is as easy as saying is alive, false, and that would be added to our database. Let's look at some other data types here. So we might use null here to indicate the absence of a value. So that's as easy as like maybe we wanted to store each person's favorite food, and for Grace we just don't know what Grace's favorite food is, so we would just put null in here. And again, that one's easy. That is just the straightforward value from JavaScript that we're putting in here. If we want to put in an array, same deal. Maybe we want to store the awards and accolades that each person in our collection has received. Just open up an array, and then we can put our values in there. Those could be numbers, but they could also be strings here. So I could create an array and grab some of Grace's awards to put them in here. And I'm going to break this out on a couple lines. I'm not going to go through adding all of them, but let's get 3 in there. And then let's also do, while we're at it, a map. So a map is really just like a JSON object. So it's an object literal in JavaScript that just doesn't have any methods. So we can use maps to store related data together. Like maybe with Grace, we want to store years of military service. So we could have years of military service, and then put an object literal here, forgetting a comma for the last one. And into this, I can define more data, and we can go more than one level deep here. We can have multiple levels of nested data, but maybe here we just need to store the start, which was 1943, and the end, which was 1986. So a map in Firestore is just a way for us to store related data together in a nested structure like we're used to in JavaScript. So that should do it for most of the basic straightforward types in here. We got integer covered with these years. If we wanted to store a floating point number, that would be easy. We just store that number like we're used to in JavaScript, and it will be all set up as a floating point number. So let's see this working with our types, and then we can inspect it in our console here. So my people collection is empty. I'm going to give this a save. I'm going to go to my React application, hit add Grace Hopper, added Grace, and then come back here and check it out. So I can see my array is stored as an array, and I can expand and contract it here. I can see the little array label. I can see favorite food, and the type over here is null, so that worked. We've got string, Boolean, string. This is telling me it's a map with a number and a number. So this is working just fine. So now we're going to add these other data types that are a little bit more complicated. Date, time, geographical point, and reference. So to get started here, let's clear out this document that we just added so that I can add it again. Okay, so working with time, let's go full screen here, requires us to look at the Firestore documentation page. So specifically, we want to look at the timestamp namespace inside of our Firestore library here. So actually, this isn't a namespace, this is actually a class here. So it's a class for representing a point in time using UTC, epoch time. So this is number of seconds since 1970. That's that's what epoch time is. It's a standard in representing time on computers, and it comes with a constructor, which is a way for us to create a new timestamp. So we can pass in the number of seconds since 1970 at midnight on the 1st of January. And then we can pass in sort of nanoseconds for a little bit of extra precision. We can also use some methods on this class like from date and from millis, and now. So each of these allow us to construct a timestamp with different parameters. So from date allows us to pass in a JavaScript date object, and it'll give us back a timestamp to be stored into our database. From millis, we can pass in milliseconds to this and get a timestamp, and .now will give us a timestamp with the current date. So whatever the current time is when you run that. So let's start, if we go back to our application here, we're going to use this now to mark when this was created. So created at, and then we want to put in our timestamp here to store it. So we're going to go into the Firebase library, grab the Firestore namespace, and then grab timestamp. So this is a reference to our class here. And once we have a reference to that class, we can call any of these static methods on it, or we could use that class to go ahead and instantiate a new, timestamp using the constructor. So to start, let's use now. So this allows us to do to get a timestamp that represents the current moment. So firebase.firestore.timestamp.now. This runs that static method, gives us back a timestamp. So if I save this, hit add Grace Hopper, check out our database here, we can see that now we have this created at that has the time when I clicked that button on my machine. So November 5th at 12:22 p.m. And then the time zone here. And if we edit it, we can see it's stored as a timestamp. And in this window, you've got a little date picker and time editing field. So if you wanted to edit that through your Firebase tools in your console, you can do that. So this is one way to add the created at time. So if you wanted to like have a to-do list where every to-do was stored with the time when that was created, this would be one way to do that, where you use the timestamp library and say .now to get a timestamp for the current time. There's actually an alternate way to do this. So let me show you that. I'm going to delete this document, copy and paste this, comment out the previous one. So there's another way, and that actually involves going into the field value here inside of the Firestore library. And this has a server timestamp method. And if we call this method, it is putting in a placeholder that then turns into a timestamp when the data reaches the server. So using this, we're going to say firestore.fieldvalue.server timestamp. So firebase.firestore.fieldvalue.server timestamp and run that function. So if I give this a save and we check out our data, make sure that's cleared, go ahead and add Grace again. We've got a timestamp here that has been added. The difference is when that timestamp is created. So the previous way that we were doing it here, our timestamp is calculated as soon as we are generating this command on the front end. And the timestamp is generated as soon as the data reaches our server. So a subtle difference here in terms of the projects that we're working on in this class, you probably don't need to worry too much about the difference here. So you could stick to just using the timestamp for your application, but just know that there's also a way to generate that timestamp on the server. So using this timestamp, so let's head back to the timestamp here. So using this timestamp class, we can also generate like her birth and death date and store that in the database too. So this from date method allows us to use, timestamp typed that wrong. But if you Google search date JavaScript, you will get the date object, the date class in JavaScript that this documentation is referring to. When it says date here, that means using this built-in type from JavaScript. So we can use this to create a new date object where you can pass in a string to configure that date object, or if you look down here, you can pass in the year, the month, the day, the hours, the minutes, seconds, milliseconds to create that date object. So we're going to use this method to store, let's call it born on and died on. And for both of these, we're going to use firebase.firestore.timestamp.fromDate, and we're going to pass in a date here. So I'm going to leave this blank for a second while we figure out the construction of that date. So if I look at the syntax for creating a new date in JavaScript, we're just going to say new date, and there's a description of what the parameters are. So if we don't pass in anything, then it uses the current time and date when we created that object. So this would be another way for us to have that created at time. We can also pass in a value, which is the number of milliseconds since the Unix epoch, that date in 1970. You can pass in a string, and there's a reference to how to format those strings, or you can pass in year, month, day, hours, minutes, seconds, milliseconds. So I'm actually going to use this one. This is going to be the kind of easiest for us to think through in this video. So we're going to have to pass in a year, which is an integer value representing the year. We're going to have to pass in a month index, which is a number between 0 for January and 11 for December, and then a day. So this is the day of the month, and it starts at 1. We'll ignore the hours, minutes, seconds, milliseconds, and we'll just let them be their default. And we can see that all of these are optional. So creating this date here, I know, let's see, I think for reference, let me copy these over here so that we can have them in the file as we're working. So here we can just pass in a new date, so we can construct that date and pass in the year, which is the first one, so 1906, then the month, December, which would be 11, since we start counting the month at 0, and then the day, which would be 9. And then we can leave the rest of the parameters out. And here for died on, we can say new date, 1992, 0, 1. And let me change the order here. Okay, so we've got our created at, and then we have born on, died at. Make sure I cleared out the last one from our database. I did not, so let's delete that. And then go ahead and add grace. We see that it worked. And if we check it out here, we can see December 9th, 1906, and January 1st, 1992. So these data types worked as expected. So using this syntax, you can get a timestamp for the current moment, and using this syntax, you can get a timestamp for any moment that you want. So that's it for timestamp. Let's now add a geographical point. So this data type is a type that has a latitude and longitude for storing a place on Earth. So maybe what we want to do with Grace is store, where she was born. We could store that as a geolocation. So back into our project, we can say birth location. And then here we need to do the same thing. We need to talk to the Firestore API to actually construct an object that represents a geographical point. So if I go back to Firestore and I look through here, I can see, GeoPoint, that is what I'm looking for. And this represents an immutable object that stores a geographical point. Immutable just means that it can't be changed after it has been created. And it tells us the latitude values are -90 to 90, and the longitude values range from -80 to 180. So this is a class in JavaScript, which means we're going to use the constructor to make it. So we're going to say new geopoint, and then we're going to pass in a latitude and longitude to construct that geopoint. So here I'm just going to Google NYC latitude, longitude, and I am looking for values that are going from -90 to 90 and -180 to 180. So I got the right values here. So I'm just going to need to drop these into my constructor. And we get to that constructor, firebase.firestore.geopoint. So here we are going to say new firebase firestore.geopoint. And I'm going to pass in that latitude and longitude. So let's grab them here. Grab this latitude, grab this longitude, give it a save. Make sure that I have cleared out this previous document. Go ahead and add Grace. And look for birth location, and we can see it's stored as a geopoint, and that is represented in our user interface in our dashboard with degrees north, degrees west. And you can edit this geopoint through the dashboard. And then basically covered everything in here, except for reference. So reference allows you to store the path to another document, so a reference to another location. And here maybe we're going to say like Grace's favorite movie is Alien. So I'm going to grab this ID. Favorite movie is equal to db.collection movies.doc. And whoops, I did not actually copy that. There we go. Storing that. So here, this doesn't make a ton of sense in our sample application, but this will just show you that you could store a reference to another document inside of one of your existing documents here. So this Grace Hopper document is going to point to the Alien document. Let's go ahead and clear out this old one. Add Grace Hopper. Check it out, and we can see our favorite movie now stores a path to that document. And we can edit it where we could paste in a different ID here. But we're good. So we finished the adding side of the equation here. And at this point, we know how to add basically any type that Firestore supports. And then on the reading side, what's going to happen is that a lot of this information is going to come to us in a format that we normally expect. When we read the document and we check is alive, it's going to be a Boolean value. But when we look at created at, born on, died at, birth location, favorite movie, because these are Firestore objects, when we saved them, what happens when they're pulled from the database is that they are converted to those Firestore objects again. So we will have some extra things that we can use on these objects that we couldn't use on just like a normal Boolean value. So what we're going to do is this button here, print data, will reach into our people location and print everything out to our console so that we can see some of the features that we get. So I'm going to create a try catch. And console log our error here. And then in the try, we're going to get a snapshot by awaiting db.collection people.get. So this is giving us a snapshot of all of the documents in the people collection. And then we can use the for each to loop over each document one at a time. Right now, we only have one document in there, but if we were to add more people, then we would be able to loop over them here. So I am going to get the data from our document by using the data method. And then let's just print out that data. So just making sure that I've got my document still in here saved from the last time I hit add, and then I can hit print data and see, okay, here we go. We have is alive, that's a Boolean. We have last name, that's a normal string. Our map came back as an object, so that's easy for us to access features. So we could say years of military service dot start or dot end to pull out those individual values. But then we can see some new information here for birth location, born on, created at, died on, and favorite movie. So each of these, let's start with birth location, is an object that can have fields, properties, and methods. So if we look at our GeoPoint documentation, once we have constructed a GeoPoint, we can call latitude or longitude to get the latitude or longitude value. And then it also has some methods, so we can like compare whether two GeoPoints are equal using this method. So for our purposes, let's just print out the latitude and longitude. Or we'll just do it like this in a console log. Give myself a template string. Grace was born at, oops, I don't need this $sign here. Data dot birth location dot latitude by longitude. So if I flip back and I print out that data, I can see I am getting the latitude and longitude from that GeoPoint. So let's look at the timestamps now. So the timestamps, we had a few of them. We'll probably just use maybe the born on one here. So this is also an object that has some properties and some methods here. And if I look back at the documentation for timestamp, now that I have an instance of this class, I can reach in to read the seconds and nanoseconds, or I can use any of the methods here. So like the toDate method will give me back a JavaScript date object that has the date in it. And we can also call toMillis to get the value of our date in milliseconds since epoch. So we can do console.log Grace was born at, and then put in data.bornon.toMillis. This will give us it in milliseconds. And if we did toDate, that is going to give us back a JavaScript date object. And if we check it out here, print data, We get it in milliseconds, so milliseconds are relative to that point in 1970. So she was born before 1970, so we're getting a negative number back. And then we're also getting that date object formatted for us to a string here. So once you get that date object, you can use any of the methods that come from the date object. So you could ask for the month, you could ask for the seconds, you could ask for the year, you can convert it to an ISO string. So any of these methods you could use once you pull that date from our timestamp. And you can use this on any of your timestamp objects. So let me just make a note here. So birth location is a GeoPoint object. So we can use GeoPoint properties and methods on it. And I'm going to copy this over here and say that born on is a timestamp object, so we can use timestamp properties and methods on it. And then the last one to check out that we stored in here is the reference to our favorite movie. And so this is just a normal document reference like we've used before. So if we check out document reference, we can grab the ID, the parent, the path. We can also use the get method to actually go ahead and retrieve a snapshot of that document. For the purposes of this demo, let's just print out the ID and path. I'm going to go ahead and copy this and say that our favorite movie field is a document reference. So we can use document reference properties and methods on it. Console log favorite movie ID. Favorite movie path. And I'm just going to make sure that I typed those correctly. So ID, yes. Path, yes. So I'm able to reach in and grab those. And we should see favorite movie ID is that ID. And then the path is the full path to get there. Okay, so with this, you should be equipped to go ahead and use any of these data types in your project. Remember that this is the exhaustive list of data types that Cloud Firestore supports currently. So if you're trying to store something, you want to think about which of these it makes the most sense to store it as. And with these special ones like reference, geographical point, and our date and time, we have to use the API from Firestore to construct objects to match those data types. And then once we do that, when we retrieve that data, we can go ahead and use the properties and methods of those objects to go ahead and make our life a little bit easier for formatting and displaying and pulling out that information.